Good morning, students. So let us continue with some more problems of particular integral related to the exponential case. Okay, so we can write down the next problem. Solve d square plus d plus 1 of y is equal to 1 plus e to the power of x whole square, where d is equal to d by dx. Okay, so while solving this, we need to find out two components for this problem. They are complementary function and particular integral. So let us try to find out complementary function first. While finding that, we need to write the auxiliary equation. What is the auxiliary equation? It is m square plus m plus 1 equal to 0. Okay. So by solving this, we are going to get m equal to minus 1 plus or minus under the root 1 minus 4 divided by 2. So that is given by minus 1 by 2 plus or minus I into root 3 by 2. Okay. So this is of complex case. That is complex roots. The roots are here complex. So what is the complementary function for that? The complementary function is given by y is equal to e to the power minus x by 2 of c1 into cos root 3 by 2x plus c2 into sin root 3 by 2x. Okay, so let us call this as 1. So this is the complementary function, right? Now we need to find out the particular integral. While finding the particular integral, we know we need to write 1 by f of d. What is there in f of d? D square plus d plus 1. Okay. What is there in right hand side? 1 plus e to the power of x whole square. Okay. So let us try to expand this term 1 plus x, 1 plus e to the power of x whole square. So by expanding that, we are going to get d square plus d plus 1 of 1 plus e to the power of 2x plus 2 into e to the power of x. Okay. So now we need to find out the value of each term. Okay, for the value of 1 by f of d. Okay, so let us split that. So by splitting, we get d square plus d plus 1 of 1 plus 1 upon d square plus d plus 1 of e power 2x plus 1 upon d square plus d plus 1 of 2 into e to the power of x. Okay. Now using the first case of particular integral, we need to replace d by a, d square by a square and so on, right? So for that, in the first term, it is 1. So 1 can be taken as 1 into e to the power of 0x. So where d is replaced by a is 0. Okay. So thereby we can write here answer as 1 plus. In the second term, the value of a is equal to 2. Okay. So by replacing d by a, d square by a square, we are going to get e power 2x upon 2 square, that is 4, plus 2 plus 1, we get 7. In the third term, the value of d is replaced by a, where a is 1, we get 1 plus 1 plus 1, 3. So this is what we get for the value of pi, particular integral. So when we finalize the answer, the complete solution is equal to complementary function plus particular integral. So that is complete solution is CF plus PI. So we need to add them. So by adding them, we get t power minus x by 2 of C1 into cos root 3 by 2x plus C2 into sine root 3 by 2x plus pi. What is pi? 1 plus e power 2x upon 7 plus 2 by 3 into e to the power of x. This is what we get as the final answer for y. Okay, fine. So now we need to take one more problem. So let us practice one more problem. Okay, right. Solve d plus 2 into d minus 1 whole square of y is equal to e to the power of minus 2x plus 2 into sin hx hyperbolic function, where d is equal to d by dx. Okay, so now for getting the solution of this, as usual, we need to find out two components. What are the two components? Complementary function and particular integral. So for finding complementary function, we need auxiliary equation. What is that auxiliary equation? That is m plus 2 into m minus 1 whole square equal to 0. Okay, so by solving this, we are going to get m equal to minus 2 comma 1 1. Two roots are equal, one is different. What is the complementary function here? That is given by y is equal to e to the power of minus 2x into c1 plus c2 plus c3x into e power x. This we write because two roots are equal. Okay, so now let us call this as 1. That is complementary function. Now we want to find out the particular integral. So for finding particular integral, as usual, we write 1 by f of d. In place of f of d, we have d plus 2 into d minus 1 whole square of the given material in RHS, right hand side. That is e power minus 2x plus, I am going to break the term here only. That is d plus 2 into d minus 1 whole square of 2 into sin hx. This sin hx can be written in terms of exponential as e power x minus e power minus x divided by 2. So hereby you can cancel this 2. Okay, so now once you cancel that 2, we can simplify further. That is given by 1 upon d plus 2 into d minus 1 whole square of e power minus 2x plus 1 upon d plus 2 into d minus 1 whole square of e to the power of x minus 1 upon d plus 2 into d minus 1 whole square of e to the power of minus x. And here we need to operate each term separately. So while doing that, we get 1 by, so let us take the first term in this manner, d minus 1, okay, whole square. In this term, if I replace d by minus 2, okay, we are going to get minus 2 minus 1 whole square minus 3 whole square, that becomes 9. What is the remaining term? I'll write d plus 2, okay, into e power minus 2x. So let us take the second term. In the second term, by replacing d by 1, we are going to get 0 in the denominator. So to overcome that, we need to multiply by x. Okay, so that we consider, and here we replace first d by 1 in the d plus 2 term. So thereby we get d minus 1 whole square term we write as it is. In place of d, in d plus 2 we put 1. 1 plus 2 is 3. So the remaining thing is e power x minus, and here even by replacing d by minus 1 we don't get 0 here in the denominator, so we can substitute for d in the third term completely. So we take minus 1 plus 2, that becomes 1 into minus 1 minus 1 minus 2 whole square plus 4. Okay, e to the power of minus x. Okay, so what we do in next step? So in next step, while replacing d by minus 2, we are going to get 0 here, right? So for that we need to multiply by x in the numerator and differentiate the denominator with respect to d. So that becomes 9 of 1 only, e power minus 2x. So then here or here also we need to differentiate with respect to d. So 3 into, so that is 2 into d minus 1, okay, to the power 1 minus 1, 1 only, into derivative of d minus 1, that is 1. So take e power x as it is minus e power minus x upon 4. In the last step we write x into e to the power of minus 2x upon 9 plus, now here if I replace d by 1, here also we are going to get 0. Okay, and here of course we need to multiply by x, it was missed. Now one more time we need to multiply by x. Okay, so that is x square divided by 3 into 2, 6. Derivative of this becomes 1. Okay, into e to the power of x as it is minus e power minus x upon 4. This becomes the complete pi. Okay, so after getting the complete pi, we need to add this pi with cf. The complete solution is therefore given by complementary function plus particular integral. So that is given by c1 e to the power of minus 2x plus c2 plus c3 x into e to the power of x plus x into e to the power of minus 2x upon 9 plus x square by 6 into e to the power of x minus e power minus x upon 4. Okay, so this is the final answer, right?